everyone, it's Sean. Welcome back to the channel. Another Klipsch SW-450. This one came in all the way from California for a repair. Individual said that he removed a handful of diodes. We got them right here in this package. And that they tested good. Not sure if that's washing out or not. Either way, that they did test good. But he needed some help getting this repaired. So what I'm going to do, actually, let's just verify that these diodes do check like diodes. But what we're going to do is, if these diodes are good, we're going to solder them back in, get this power supply board back onto back into the plate, and we'll troubleshoot it from there. Okay, that seems to be fine. Yep, there we go. 0.79. Yeah, as I flop it all over, no issues so much with any of that. Okay, let me get these soldered back in, everything back together. We'll actually do some troubleshooting. Well, I've got those diodes soldered back in, everything reconnected. Let's power this guy up. I'll turn on my isolation transformer variac. Time for the dim bulb tester. No smoke, that's good. All right. Let's I hear something. Something doesn't sound too happy. All right. By just plugging in AC, I hear something not good. Potentially on the switching side. Bad transformer or something. Let me check again. Definitely not sounding good. Let's let me pause this and get this somewhere a little more comfortable for me to work on. Okay, I've gotten this a little bit more comfortable to work on. I hear clicking, and what this sounds to me is like a switching issue. And both of these plates are heating up. This is probably going to be a cap issue on the high DC side, the regulated side. My 48, as you can see, it's in and out. That should be around 9. I'm seeing 8. And we got an issue on the positive 9 side as well. So yeah, this is looking like caps. Let me do like this. We'll unplug this from the supply. I'm going to disconnect this cable so we can get the load off. Man, that thing is hot. Hopefully there's no issue with our regulators. Those transistors or IGBTs or MOSFETs or whatever they are. Okay, and we'll plug this back in. Yep, back in now. And how much are you willing to bet without a load on there? We got the voltages. Yeah, negative 48 right there. There goes the negative 9, positive 9. Okay, so primarily the first thing we're going to look at is capacitors, which means I got to dig this out. We're going to pop out all those caps and take a look at them. Place the bad caps that were down in there. With everything unplugged, voltages looked good. Everything was steady. Plugged back in, same condition was occurring, especially with losing this. These two, J13009 TAC2, what are those components? High voltage switch mode application. Yeah, they were getting super hot. This was getting kind of hot. So I decided what I would do is I would try to determine if the issue was over here on the power supply side or the amplifier side. And so what I did was I just disconnected this lead here that had my negative 48 on it. And I left the 9-volt in and made some measurements. And here, I'll just show you. I think we got our... There goes our negative 9. Guy didn't send the standoffs with these, so I have no way of 100% securing this. Come on now. Yeah, our 9-volt is positive 9-volt is down a little bit. I think that's because we got a bad cap somewhere in here. But here, let me look at the... There goes the 48. So the issue was I disconnected this on PJ5 from the board. And with my bench top power supply, I started to inject a voltage into it. And I couldn't even get up to and I started drawing like 2 amps as soon as I started cranking up the voltage. And so obviously I have a short over on this side. And then I took my thermal camera to it and found out that, yeah, we have a bad IC, and that's what's really dropping us out there. And so let me disconnect this. The bad IC is actually this guy right here, STA-516 Bravo. Probably not incredibly visible for you. Hold on a second. I'll bring over a different camera. Yeah, there you go. You got it magnified. STA-516 Bravo, which is basically a 4-channel or quad amplifier. Yeah, quad power half bridge, 65 volts, 7.5 amps. This is what's got to get replaced. This is what's bad, and that makes perfect sense. If you have output amplifiers that are bad, that's going to have an effect on your input voltages dropping out like that. So I'll have to get one of these on order. I'm going to recommend a full recap to the customer as well, and then we'll go from there. Well, parts are in. I think I'm going to start with replacing this IC right here on this board. So I need to prep the spot and get the soldering. So we got the IC replaced. I think I'm going to test it at this point before I go through and start recapping. And I budgeted with the owner of the device for a full recap, but what we're going to do to try to save him some money is just test some caps and only replace the ones that are absolutely needed. Because if their capacitor is this good, why would I change them out and just charge the customer? That doesn't quite seem right. But I did price them for a full recap, and then after I'm done testing and replacing them, he'll only pay for what was replaced. Anyways, with that IC in, I've got AC plugged in. I'm going to turn it on, and let's hopefully we got some good news. All right, she is on, and no smoke is coming out, so, and she sounds a lot better. Not hearing any cut in and cut out. Let's check our voltages. First one's going to be our 48, and it's there. Let's look at our -9, and it's there. And let's see if my +9 is back, or if it was that driver IC that was kind of causing it issues. Yeah, I'm not getting the +9. Could also just not be making a very good connection on those pins. Give me a second to reorient the board. All right, here we go. Again, -48. -48 is there. Again, let's look at our, or excuse me, 48. Let's look at our -9. She's there. And our +9. We're sitting at 5.3. So we're still having an issue with that voltage rail. But she's not as bad as she once was. Let me power this off. And what I like to do before I start replacing caps is see if we're getting any audio out whatsoever. Actually, I'm not going to do that. I was checking the speaker output with that 9-volt rail missing. I took my thermal imager, and these caps here are getting pretty hot. The IC is not hot anymore, but I'm seeing a DC voltage on these on the speaker output. I don't need to be seeing that, so I'm going to replace the caps here and see if that resolves that issue. All right, I replaced those capacitors, but they weren't really too far out of tolerance. They were aged. They were like right at the cusp of their upper limit. So yeah, they were leaky. I replaced them with high temp capacitors. The 22 microfarad fits in pretty good. The 330 microfarad high temp cap is a little bit bigger than the previous one. So for comparison, here goes, I think, a 330 right there. Yeah, there goes a 330 right there. And then the new one, you can definitely see the size difference there. But because they weren't so far out of tolerance, I was like, okay, so we got a bigger issue here. And I started looking, and I see this LD117 alpha. This is a voltage regulator. As a matter of fact, the 9-volt rail would feed into our voltage in pin. Center pin will be voltage out, and then the outside pin will be ground. But here, let me put my multimeter here. Just do a little diode check. Okay. If I go from this, I think this is a good ground pin. Yeah, there we go. But look on the center pin, my voltage out. So this voltage regulator is bad. That was most likely what caused the this IC down here to go bad.
our amplifier, whether or not the bad cap in the 9-volt rail from the power supply had anything in addition to do with it. Yeah, I know that pin right there moves, but it's because the trace came up. It's moving with the trace, so we're good. I'm not too sure, but we definitely have to replace that voltage regulator as well. So long as it's the voltage regulator and not the decoupling capacitor or filter cap there at the back end of it. Yeah, so I'm gonna have to remove the cap and then test again to see if it's still shorted. Okay, cap is removed. Do we still have a short between those 2 points? Let's find out. Yes, we do. Right, so the voltage regulator has to come out now. Let me try to get it out for us. All right, it's out of there. Let's check it again. Still shorted. Might need to allow some time for this everything to cool down. I'm seeing 1.5 ohm across that. The IC itself shorted. Let's check it. No, it doesn't appear to be. That center pin is tied to the back. So yeah, the IC itself is not shorted. Okay, I'm gonna poke around the board a little bit longer to see what else I find. Well, I've done a lot of prodding around on this board, and by a lot, I mean a lot. I finally decided to inject 1 volt uh, into here to see where that short is coming from, and we'll zoom in. As a matter of fact, I'll move some things out of the way. And yeah, let's see what's drawing the current. Again, all this is tied to that 9-volt rail, the one that's out. So I want to see why we are shorted. And we can see what's heating up right there. Okay. Right there. All right. That will be this STA309 alpha, which I believe is basically the DAC, digital audio encoder, affords you to do other things as well. For this board, I'm going to remove it, but it might be game over because I think these things are programmable. But I'm not too sure. Maybe I can order one to swap it in, and we'll see what happens. But there's no guarantees on this. If the DAC is blown and it has to be programmed, then this board is no good at this point. So let me get this removed, and we'll come back and we'll check that short again. Okay, now that I have that IC removed, We'll check this 3.3 volt regulator going to the ground. Yep, continuity. Now let's go to the V out pin. And now we have a diode drop. Yep, so we're going to replace this IC to 100% verified at this point. Got the new IC soldered in. Just going to go around and check the legs on it. Might notice some of these legs have no pads underneath them. Typically, that one's moving this trace right here. That one is it on? Yeah. Probably take a voltmeter to that one and check between there and the cap later. Obviously, no pad there. This one's on. That one's on. That one's on. Now, some might be embarrassed to show pads missing on an IC. I'll go ahead and tell you these pads came up even when I was using low melt point solder to get up the IC. Now, if you're applying low melt solder to IC pins and you're working the pins, and if you apply heat to, say, lift up the IC as a whole unit, meaning I'm using a hot air station after I've applied low melt solder all the way around, you want to make sure that the IC is fully lifted itself, where it can kind of skate a bit back and forth before you pick up and lift them off of the pads that are here. I would always suggest low melt solder and flux when pulling an IC. Don't ever put a pry tool underneath it if avoidable, because if you try to pry while heating, you're typically pry up pads. That one was kind of stuck and came up. You'll see that I have a lot of missing pads, and that's not because I didn't adhere to the rules that I'm kind of laying out for you. Those are just, they're guides. That's what I would highly recommend. Sometimes on a PCB, even if you're practicing all those precautions, the underfill or the epoxy on some pads is old. And even when you go back through, so this happened when I was cleaning up the pads with flux and a soldering iron and a bit of braiding material. If the underfill or epoxy on the pads are old, sometimes they'll just come up, and sometimes that's not avoidable. Now, in the case of this IC, the ones that lifted like this right there, that's non-existent, those pads, they're not going to any traces or anything else on the board. There's a lot of pins on this IC that are just not used, if I could put it that way. So when engineers select certain devices, they're using this STA 3939 alpha, right? I see here, because it's going to serve the purpose for what they need, but it has multiple inputs and outputs. I think up to like 4 or 5 or 6 different channels. I'm not too sure. I'd have to go back and look at the data sheet, but only 2 channels are being used on this for our subwoofer. So the rest of them, those traces or pads, they go to nowhere, anywhere on the board, but they're still used to kind of anchor the IC down. So while cleaning up the pads, cleaning up the low melt solder that I used to take the IC off, no pads had lifted up then, but while cleaning the pads using, 90 SN95 or 94, whatever, 10 lead solder and flux, several of them did unfortunately come up, and that's just the nature of the game. There was only one pad that came up that completely ripped, and that was this one right here, where you see this small wire that I have to replace the pad, and then that wire runs through a trace that's right here on the board that follows over under and then shows up over here at this resistor. So I'll check between that pin and that trace using a multimeter. Obviously, these pads came up here, and these last several pads feel like they're on the board. They're soldered in, so they're good. Methods for soldering. Do what you're comfortable with. Okay. I often, when I'm having to solder in an IC that is this big, I don't often record myself doing that because I'm using a microscope, and that kind of gets in the way of certain things I want to see, just because of my big old head having to come across my desk area. Okay. And when my big old head is coming across the desk area, oh, I just realized that camera wasn't working. There we go. When it's coming across this desk area like this, I'm trying to get in close to a little monitor I have right here up at the top. That's actually, you see it right here in the corner, that's tied to my microscope here. And I'm trying to look as close as possible. And when I have other recording devices and everything going on, that's just more things that are in the way. I'm wearing a headset with a microphone on it. It's just a lot more things that I'm having to concentrate on other than the work at hand. So you don't often see me record this. But what I do is I typically pre-tin all my pads. Then I lay down a bead of flux across everything. I situate my IC, make sure that all the pins match up. And then you can use a heat gun, reflow station. I used a reflow station to make the initial tack. I waited for everything to get a little shiny. I removed the reflow station away from the PCB, allowed everything to cool down, then put pressure on the middle of this IC using the back end of my tweezers, or I also sometimes just use the front end, whichever allows me the most surface area without getting in the way of the reflow gun, hot air gun. And then I reflow it again and let it cool down. Afterwards, I check the pins, and the ones that are loose, I'm one by one using the tip of my soldering iron to solder them back in place. Like I said, there's no pressure to try to get this type of stuff done fast. You do it at your pace, and don't get over anxious of getting it done. That's another reason why I don't record this section, because it'd just be a huge speed up. I take my time when doing ICs like this. I'm not in a rush. Okay, that's small traces. It's a pretty small IC. I mean, here goes my pinky fingernail right there. And yeah, I need to trim my fingernail. Yeah, you can see how small that is. Okay, here's can I get this into the camera? There goes the tip of my tweezers right there. Here they are underneath the camera. You can see that these traces are about the size of the very tip, at least in width, of my tweezers. That's incredibly small traces, and there's a lot of them all the way around. So do what you're comfortable with. That's what I would recommend. Of course, keep in mind the suggestions I've made. There's probably going to be somebody in the comment section going, "Oh, you're looking traces, blah, blah, blah." I don't care. They don't go into anything. The IC is going to work. The circuit board is going to work. I've been doing this for years. If you want to scold me for something like a trace popping up because of old underfill or epoxy, whatever, your comment will probably get deleted. Because I just don't like reading and seeing stuff like that. Make your own YouTube channel, do your own thing, teach a different method. Leave my YouTube channel alone. We don't even want you here, to be honest. So there we go. It's on the board. I need to get everything together, and we're going to test out our amp again. I've got the amplifier board back in, and AC line plugged into the back. We're going to power it up again for the third time now, fourth time, who knows. Contact. I see no smoke coming out. That's good. Put that into the on position, and I need to check to see if we have DC on the output terminals. Let me put that there. Let's see. That's much lower. That might be just a DC offset. Let me check this side. Yeah, that's a lot lower. It was a lot higher than that. That doesn't really give me much of a cause for concern. That could just be the DC offset. Earlier I was seeing a much higher DC voltage. Okay, so I need to take and verify our 9-volt rail now. See if that is back to normal. Put this up here, and we'll come in through the top. Negative 9-volt rail is there. What about the positive 9-volt rail? How's that looking? All this stupid glue down in there. Yeah, 9-volt rail's back. We're not down to 5 volts. So that's so much better. I secured it. We are looking good. And, you know, I think when I first tested the speaker outputs, I was getting like almost like 20 volt DC or something crazy. But only seeing 3.2. DC voltage is not good for speakers. That is low voltage. That might just be the DC offset. I think I'm good enough to power. And I don't talk about this often. You see how they're both equal to each other? Okay. I don't talk about DC offset or checking the speakers often on my channel, but that is something you should do. This has been an incredibly difficult SW-450. This is actually the first one on this channel where it just hasn't been caps needing to be replaced. We've had to replace 2 ICs on the amplifier section because it was blown. So what I'm going to do is I'm going to replace the thermal compound on this guy right here. I'm going to get some things cleaned up, and then we're going to test it using a signal generator and a oscilloscope. Well, I did have this set up to test, and I wasn't getting an output, and actually had to take it apart and replace our potentiometers here. The volume pot was not fully working. I think the rakes on the trace were somewhat attached. Occasionally you get continuity, occasionally you would not. So whatever burned up those ICs also burned up this. I went ahead and replaced both pots. They now actuate smoothly versus being a clicking type. And they'll last perfectly well inside of this amplifier. From my SIGGEN, I've got an 80 hertz tone being produced at 1 volt peak to peak. I'm actually going to drop that down to 500 millivolts. And SIGGEN is hooked up. Okay. SIGGEN is going to the left LFE input, and then my O-scope. By the way, let me move the camera over here for a second. You notice that I have 2 channels activated on my O-scope. See how I have individual probes on the speaker output terminals here? This is not audio and then return across the speaker. They feed 2 signals at out of phase to the speaker. I don't like how Klipsch does this, but the signals each half the waveform go through the speaker and combine and produce one full waveform. I'm not a fan of how Klipsch does that. You know, I just won't get into it at all. But we'll go ahead and keep this. Right now it's on 40 hertz. I'm going to turn up the amplitude a bit. You can see that we begin to get a signal there. Well, keep in mind, my low pass is set to 40. I wouldn't expect much of a signal at 40 hertz. As I turn up the amplitude, you can see with a 0.5 volt peak to peak input, we're only getting about 8.4, 9.2 volts out on the oscope. That's off of channel 1. Channel 2 is fairly symmetrical, so I would assume that it has the same readings. Actually, let me pause and add that to my scope. Channel 1 and 2 now added in there, and you can see that the peak to peak voltage, actually, you could call it that, it's only half a waveform. They're both in there. Okay, now as I increase the LFE, I should allow more of that frequency through, and we should start to see that increase. And we could actually see that the oscope basically has the ability to count that frequency. And yes, that is, we are producing an 80 hertz tone, now up to 23.2 volts. If I increase the LFE more, you'll see that the more of that signal allowed through, the higher that amplitude goes, right? LFE, low pass filter will pass anything at the setting, and below higher frequencies are to be attenuated. That's how LFE works. I can decrease the gain with my actual volume knob, though. We see that volume decreases over both of those, so that's good. I could turn up the LFE a bit more. We would probably see that peak to peak voltage increase, but we're getting it's a very good linearity. I would say that that portion is working. Let me go to the right channel. So let me turn all this down. We're going to take it off the LFE input. Let's go over to the right channel. We'll just turn up the amplitude. Now the right channel, I'm not sure if the LFE should have any impact, but it looks like it does. It looks like it. Ooh, yeah. Again, not the best components used in this thing. Like I said, I don't like the way how they combine these signals here. That's in bypass. You can see that that's kind of overdriving our signal there. I just don't like that. But anyways, LFE input works on the right channel as well. I wouldn't think it would, but I guess it does. So as these two audio channels are combined at a speaker, if I was to let's couple them to let's see, channel 2, let's couple you to ground. Channel 1, let's couple you to ground. We're going to move you down to there and move you up to there. Basically put them on the same thing. DC AC, channel 2, DC AC. You can see that you have a full wave now across basically both lines. And so you technically have a full signal there at the speaker, but you would traditionally have one that goes more negative and one that goes more positive. They do it by taking the signals out of phase. I just really don't like how that is accomplished. There are a lot smarter individuals than me that can comment on that. I prefer seeing a full sinusoidal waveform combined before coming across a speaker. Okay. But this is essentially repaired now. Man, this one kind of got my goat a bit. I've had a rash of amplifiers get my goat, especially those with issues in the audio amplification section versus the power supply. Although I also have a power supply in my office I've been working on for like 2 months now, still haven't fixed. Man, I've got a lot of things in my office I'm trying to get repaired and out the house. I guess what I could do is I could kill the SIGGEN for a minute. I can hook these terminals maybe up to a speaker and we can feed a tone through it. So yeah, why don't I do that? Well, SIGGEN set for 80 hertz, half a volt peak to peak, 500 millivolts that is. That's coupled to the right channel input of here. Got the terminals out, going to an Onkyo subwoofer for Onkyo home theater system. Nothing special about it. It's just a woofer in a box. That's it. Let's turn this on. Okay, that should now be on. Let's turn on our output here. Okay, and let's increase the amplitude. And let's see, if I change the LFE, we can hear that it allows more and less through. Okay, so why don't we do a just run through a few frequencies as well. I think that works pretty good. All right, well, suppose it's now time to button this one up and get it back to the owner. If you've enjoyed this video and have traveled along with me to learn more about how to repair Klipsch subwoofers, you know, the past several ones were just power supplies. This one was actually a fault with the audio amplifier section as well, and several faults. 2 ICs, several caps, and potentiometers that need to be replaced. So let me know how you like this video. Leave comments in the description. If you're new to the channel, please consider subscribing. Why not? You're already here. If you're in need of a repair, find my link in the description. Takes you to my webpage where you can fill out a document, send it in. We'll do a discussion from there. Anyways, thank you for watching. Take care and goodbye.
Mark?